When people hear that I run language models locally on my own machine, the image they usually get is a rack of servers humming in a data center, banks of graphics cards, some kind of serious engineering setup. And I understand why. The AI coverage you see online tends to focus on the biggest, most expensive systems, which makes it easy to assume that anything smaller is not worth talking about. But the setup I actually use is sitting in my spare room. It runs off a single consumer graphics card that is a few years old, and it handles a surprising amount of real work every week. This video is not a how to get the best AI performance possible. It is the honest story of the setup I actually run, what it is genuinely good at, where it clearly falls short, and what I would tell someone who wants to start doing the same thing. The first thing to understand is what a local runtime does, because the terminology around this can get confusing fast. When you run a language model locally, you need a piece of software that loads the model into your graphics card memory, listens for your questions, does the computation, and sends back a response. That piece of software is the runtime. It handles all the low-level work of talking to the hardware and serving the model so that you can just send text and receive text back. On my machine, I run one of the open source runtimes that have become popular for this job. It starts up in the background, it exposes a local address I can send requests to, and from that point it behaves a lot like calling a remote API, except everything stays on my machine. Nothing leaves the box. The runtime is not glamorous, but it is the engine the whole setup runs on, and choosing one that is stable and actively maintained matters more than most of the other decisions I made getting started. The models I actually run. On top of that runtime, I run a small rotation of open models. I'm not going to name every version here because this space moves fast and version numbers go stale quickly. But the shape of my choices has stayed consistent. For general text work, I use a mid-sized model in the 7 to 14 billion parameter range. These are the models that fit comfortably in the memory I have, run at a reasonable speed, and handle most everyday language tasks without embarrassing themselves. For code specifically, I use a model that was trained heavily on programming tasks, because code models have different strengths from general chat models, and the difference is noticeable. I do not run the largest models available because they do not fit in my memory without serious compromises, and I would rather run a smaller model well than a larger model badly. My choices are shaped by what fits in the hardware I have, and that is a constraint I work with honestly rather than pretend does not exist. The hardware reality, let me be direct about the hardware because I think this is where a lot of people talk past each other. I am running a single consumer graphics card from a previous generation. It is not new, it is not the most powerful thing you can buy, and it has a limited amount of memory. That memory ceiling is the most important number in my whole setup. Every decision about which model to run and in what form comes back to that number. On the plus side, a used consumer card from a few years back is cheap to acquire, uses normal household power, and sits in a regular desktop case. It is not a server build. It is a PC in a room with a normal power outlet. The people who tell you that you need exotic hardware to run local models are often comparing the wrong things. You do not need enterprise hardware to get real value out of running models locally. You need realistic expectations about what hardware at your budget can and cannot do. What quantization means in plain terms. One of the key reasons that modest hardware is workable is something called quantization, and I want to explain it in plain terms because it gets talked about as if it is complicated. A language model is stored as a huge collection of numbers. Each of those numbers has a precision level, meaning how much storage space it takes to record it accurately. The default is quite precise and takes a lot of space. Quantization is the process of rounding those numbers down to a lower precision, which makes the whole model smaller and faster to run. The trade-off is a small reduction in output quality. Think of it like compressing a photograph. A lightly compressed photo looks almost the same as the original. A heavily compressed one starts to look muddy. Quantized models work the same way. A lightly quantized model loses very little quality and takes up much less space. A heavily quantized model takes less space still, but the outputs start to degrade. I run moderately quantized models, the kind where the quality drop is small and the size reduction is enough to matter. That choice is what makes it possible to run genuinely capable models on the memory I have. For attributable reasons, Now I want to be honest about what this setup is actually good at, because I have seen people either oversell local AI or write it off entirely, and neither is right. The first thing local is genuinely excellent at is privacy. When I am working with my own files, my own notes, my own drafts, nothing leaves my machine. I do not have to think about where my content is going or who might be training on it. For me, that matters with certain kinds of work. Not every task is sensitive, but the ones that are, I want handled locally. The second thing it is good at is cheap, bulk, repetitive work. When I need to run the same kind of task many hundreds of times, the marginal cost of one more request locally is basically nothing. There are no API tokens counting down, no monthly spend creeping up. For high-volume repetitive text processing, local is the economical choice by a wide margin. And the third thing it is genuinely good at is always being available with no rate limits. At 2 in the morning, when I am in the middle of something and do not want to wait or worry about quota, local is just there. No outage, no waiting in a queue, no limit on how many requests I send in an hour. Where local honestly falls short. But I have to be equally direct about where this setup falls short, because pretending otherwise would make this video useless. The honest answer is that the open models I run locally do not match the best frontier models on hard reasoning tasks. If I give a difficult multi-step logic problem to my local model and the same problem to a top-tier paid API, the paid API wins, often by a lot. The gap is real and it is not small on the hardest tasks. My local setup also struggles with tasks that benefit from very long context windows. The biggest frontier APIs can hold an enormous amount of text in one request. My local models handle shorter contexts and long documents need to be chunked or handled differently, which adds friction. There is also no ambient knowledge update. Frontier models are regularly updated and their knowledge stays relatively fresh. My local models are snapshots, and what they know is frozen at their training cutoff. For questions about recent events or fast-moving topics, that limitation shows. I am not listing these to be down on local AI. I am listing them because knowing the honest limits is what lets you use it well. How I route between local and the paid API. The practical answer to all of this is that I do not treat local and paid as competing choices. I route tasks between them based on what the task actually requires. Private files, anything sensitive that goes local always. High volume, repetitive work that is not difficult that goes local because the cost math is obvious. Quick lookups, drafts of things I will rewrite anyway. Any task where a good enough answer right now is better than a great answer later, those go local. But when I need the best possible output for something that matters, hard reasoning, a task where a mistake is expensive, or a question that needs genuinely current knowledge, that goes to the paid API. I think of the two as complementary tools with different profiles, not as one being the right answer and the other being wrong. The routing decision is not complicated once you know the honest strengths and weaknesses of each side. Assigns a task should go local. Let me be a bit more concrete about the routing because I think the principles are easy to state and easy to forget in practice. The clearest sign that a task should go local is when you are doing the same thing many times and the task is not hard. Extracting a field from a document format, reformatting text, classifying a short piece of content into one of a few categories, these are exactly the kinds of tasks where local performs fine, and doing them through a paid API would rack up cost for no quality benefit. The other clear sign is any time the content is something you would not want stored somewhere else. Even if a provider has strong privacy commitments, running it locally removes the question entirely. And the third sign is when you are experimenting. When you are iterating quickly and do not yet know what you want, burning through local requests costs nothing and lets you think out loud without watching a usage meter. Signs a task should go to the paid API. The clearest insight a task should go to the paid API is when quality is the entire point and you cannot afford a wrong answer. A piece of writing you are going to publish and put your name on, a complex decision where you want the best reasoning available, a task that depends on knowing something that happened recently. These are the cases where paying for access to a stronger model earns its cost cleanly. The second sign is when the task requires a very long context. If you need to send the whole document and have it reasoned about together without chunking it yourself, a frontier API is usually the practical choice. The third sign is when the task is one-off and rare. If you only need a particular kind of answer occasionally, running a whole model locally to handle it is the wrong tool. The paid API handles it in a single call with no setup. What I would tell a beginner, if you are reading this and thinking about setting up local models for the first time, here is what I would actually tell you. Start with the smallest model that does the job you have in mind. Do not start with the largest model that fits your memory. Start small, get the whole stack working, understand what the outputs look like, and then scale up if you have a clear reason to. The second thing is to treat quantization as the normal way to run models, not a compromise of last resort. Moderately quantized models are excellent, and the quality difference from a full precision model is small for most uses. There is no reason to chase full precision versions on consumer hardware. The third thing is to be patient with the setup. The first time you get everything running and send a request that processes entirely on your own machine, it is a satisfying moment, but getting there involves some configuration and some reading. That is normal. It gets faster to set up once you have done it once. And the last thing is to be honest with yourself about what local is for in your specific workflow. If you go in expecting it to match a frontier API on every task, you will be disappointed. If you go in knowing what it is genuinely good at, you will find plenty of real use for it quickly. The local stack I actually recommend thinking about, rather than name specific software versions that will be out of date by the time you watch this, I want to describe the shape of the stack that works for me so you can find the current best option in each slot. You want a runtime that is actively maintained, has a simple API format, and works with the hardware you have. You want a model in the range that fits your memory at moderate quantization. You want a way to send requests that feels natural to you, whether that is a simple chat interface, a script, or something that hooks into other tools. That is really the whole thing. A runtime, a model, and a way to talk to it. The complexity people imagine is mostly in the initial setup, and once that is done, using it is not different from using any other text interface. Staying honest about what it is, the thing I keep coming back to with local AI is the importance of staying honest about what it is and what it is not. It is not a replacement for the frontier APIs. It is not going to close that quality gap in the near term for the hardest tasks. What it is a genuinely useful, private, cheap, always available option for the right category of work. And for that category, it is excellent. The mistake I see most often is people measuring local models against the best possible alternative for the hardest possible task, finding them lacking and concluding they are not useful. The right comparison is whether this tool does the specific job I have in mind at the cost and privacy profile I want. By that measure, my local stack earns its place every week. If you are curious about building your own local setup or just want to follow along as I keep using and improving mine, subscribe and follow along. Thanks for watching, and I will see you in the next one.